Okay, hey guys. Yeah, so obviously I'm not here today, but hopefully teacher is able to get the YouTube video up for you. So just because I'm not here doesn't mean we can't start into our next unit, okay? This should hopefully be review. Going to be starting trigonometry, and we're going to start with the Pythagorean theorem. Okay, so a couple of fun facts about trigonometry. The word trigonometry comes from the Greek words meaning triangle or trigonon and to measure, metron. So trigonometry, measuring triangles, okay? So remember, all the triangles add up to 180 degrees in a triangle. Okay, so no matter what kind of triangle you have, just like something like that, all the angles in every triangle will always add up to 180 degrees. Now, does anyone know who this guy is? He used to work with the ancient Greeks. If you don't know, that's okay. He is Pythagoras, okay? So Pythagoras helped come up with the Pythagorean theorem, okay? So the Pythagorean theorem can be used to find the lengths of any sides. Okay, it's only going to be for side lengths in a right triangle if the lengths of the other two sides are known. Okay, so right triangle has what we call a right angle, which is a 90-degree angle. Okay, so we have another diagram below where we'll label it, but that is our right angle. Okay, so the Pythagorean theorem is a squared plus b squared equals h squared. You might have seen as a squared plus b squared equals c squared. I like h because we can say that h is the hypotenuse. Okay, so right away we know that h is the hypotenuse. And this is going to be the longest side of the triangle. Okay, so when we label our triangles, we always want to see, okay, what's my hypotenuse? And then we can work our way from there. Okay, so let's label everything on our diagram. So here I have a triangle, which is my longest side. Hope everyone's yelling out that this side right here is my longest side. So this is H. Okay. It doesn't matter which one we call A, which one we call B, as long as we have H identified correctly. Okay. So this side we can say is A, this side we can say is B. But if we said B and A, that's okay. It doesn't matter which is which. H is the important one. Okay. So here is our right angle. Right angle, and it is exactly 90 degrees. Okay. So the other thing I want you to see here is that H is always across from the right angle. Okay, so your hypotenuse is always across the triangle. So it's always across the triangle from the 90-degree angle. Okay, so we have our H, our hypotenuse. That's going to be across from our right angle. It's important to know that H is the longest side and across from the 90 because we're going to be talking about H when we talk about SOHCAHTOA as well. Okay, and then A and B are also labeled here. Okay, again, this one could have been B, this one could have been A. That one doesn't matter as much. It's the H that's very important. Okay, so just going back up here, what we have is A squared plus B squared equals H squared. Okay, so if we take A and square it and add that to B and square it, that will equal our hypotenuse squared. And then that's how we can calculate any side length. So if we know A and B, we can calculate H. If we know A and H, we can calculate B, or if we know B and H, we can calculate A. Okay. So I don't think this will work through PowerPoint, but I do have it here. Hopefully, comes through okay. The video. So here we can see that we have a right angle triangle. So this would be A here. This will be B here, and my hypotenuse is alongside here. So what we have is a square of A and a square of B. Okay, so we have a squared and b squared. That's why like the 2 is squared because it actually forms a square. Okay, so these are both filled with water, and you'll see that if a squared plus b squared does equal h squared, if we take whatever's in a squared and whatever's in b squared, and they turn upside down for h, we should completely fill. You can see that the water is pouring out of our a squared and b squared, and it's going all into the h squared. And it fills it up exactly. Okay, so now, oops, all of b is empty, and all of b squared and all of a squared is empty, and it completely fills up our h squared. Okay, so this shows that a squared plus b squared equals c squared. Okay, so let's actually start calculating it now. So we want to find the missing side lane. So we have 6 and 8. So the first thing we want to do is label our triangle as H, A, and B. Okay, so if you look here, our x that we're looking for is actually the longest side. So x is actually equal to our hypotenuse h. Okay, and then it doesn't matter what we call A and what we call B. I'm going to say A is 6 and B is 8. Okay, now using our formula, a squared plus b squared equals h squared. What I can do is sub in 6, 8, and h. Okay, so I'll still have a squared plus the b will be squared would equal h squared. But now I'm going to call them, my a equals 6, so I have 6 squared plus h squared is b equals x squared. Okay, and now I'm going to simplify my left side. So we need to find out what x is, but first we need to simplify this down to one number. Okay, so 6 squared is 36 plus 8 squared is 64. That still equals x squared. 36 plus 64 is 100, and that equals x squared. Now, am I done? No, I still have this x squared, but I want to find out what x is. So how do we get rid of a squared? Remember, we take the square root to get rid of a squared. Okay, which means we'll also have to take the square root of the right side. Okay, so to get x by itself, you have to do the square root of 100. And the square root of 100 equals 10. Okay, so we don't have any units here, so we won't worry about that for this question. But here I have x equals 10. Okay, so if my side lengths are 6 and 8, this side length is 10. Okay, let's try another one. Here we have 12, 8, and x again. But what's my hypotenuse? Okay, my hypotenuse isn't x anymore because it's not my longest side. And it's also not across from the 90 degree. 12 is actually my hypotenuse. Okay, and then I'll have, we'll call 8 equals b, and this time a will equal x. Okay, so now I have a squared plus b squared equals h squared. And now I sub in all my numbers. Okay, so a, I'm saying that is x, so I'll just keep that as x squared. If you leave it as a squared, that's fine. You're just solving for a variable. Okay, next, b equals 8, so I'll have 8 squared here, and h equals 12, so I have 12 squared on the right. Now I'm going to simplify it a bit. So I'll still have x squared here plus 64. Oops. Thank you. Plus 64 equals 144. Okay, now I want to get x by itself, but first I have to get x squared by itself. So I'll move my 64 over to the right side of the equation. And when 64 moves over to the right, I'm just left with x squared here of 144 minus 64. Since it was adding on the left, it'll become subtraction on the right. Okay, so x squared should be equal to, I believe x squared will equal to 80. Now remember, to get rid of the squared, I have to do the square root on the other side of the equation. So of x equals the square root of 80. And this time we won't get a whole number, but that's okay. Okay, we'll just round it off to just one decimal place for this class. Okay, so the square root of 80 would be equal to 8.9. Okay, so you can do that in your calculator. So now if we have 12 and 8, this side length will be 8.9. Okay, so that's what we can figure out with triangles, but what happens if we get a word problem? Okay, so this will be our last question for today. So Crystal is crossing an intersection that has a diagonal of 12 meters. If one of the streets in the intersection is 9 meters wide, how wide is the second street? Okay, so what we want to do is draw this out first. So I have an intersection here with two streets, okay? So this street's going this way, and the street's coming this way. Okay? So let's say Crystal is at this corner. Okay? Now it tells us that one of the streets of the intersection is 9 meters wide. Okay, so we're going to say that this street here is 9 meters. Okay, then it tells us that the diagonal is 12 meters. If you don't remember, a diagonal goes corner to corner. So we start here and go down. Corner to corner is going to be exactly 12 meters. Okay, and now we want to find out how wide the second street is. So we know that this one's 9 meters. We want to find out how wide this street is. Okay, so I'm going to call that X because we don't know what it is. But if you notice here, assuming that we're not talking about like Niagara Street that's cutting everything in half, but if we're looking at, say, Limwell and, well, it's not quite Grantham, but Grantham doesn't cut through, but Limwell and Vine Street, let's say. They cut each other at 90 degrees angles. Okay, so right here is 90 degrees. So every intersection like this, like that's a four-way stop, is going to be 90 degrees. Okay, so we have a right angle triangle. We have a side here, and our side here. Okay, so we can use a squared plus b squared equals c squared. Okay, make sure if you haven't done so already, copy down the diagram because it helps you visualize a problem to help and it'll help you get the answer. Sorry. A squared plus b squared equals h squared. So let's find out what's our hypotenuse, what's our a, and what's our b. Well, this one that goes side to side or corner to corner is going to be the biggest side length. It's also across from the right angle. So 12 meters is our h. And then either of these can be a or b. This time let's make x b. And we'll make 9a. Okay, so if I'm looking at this, I can sub in all of my variables now and numbers. Okay, so I just said that a is 9 meters, so a equals 9. Plus, I said that b is x, so I have x squared. And that is equal to my hypotenuse, that is 12. Okay, now I'm going to simplify these to get rid of the squares. So 9 squared is 81. Plus, I'll have x squared. And that's going to be equal to 144. Okay. Now, I need to get x by itself, but first I need to get x squared by itself. So to do that, I'm going to move my 81 over to the right side. So I still have x squared. That's going to be equal to 144 minus 81. Okay, and that, because remember, 81 is positive over here, so when it comes to the right, it's going to be negative. So now I'll be left with x squared equals 63. I'll have to take the square root of each of these to get rid of that square. So x equals the square root of 63. Therefore, x equals 7.9. Okay, and look at it was a word problem, so we're given units, we're given meters. So if you're given units, make sure your final answer has those same units. Okay, because the street isn't just 7.9, it's 7.9 meters. Okay, so if one street is 9 meters wide, this is 12 meters diagonally, then this street will be 7.9 meters wide. Okay, so that's it for today. Hopefully this was more of a review lesson than new information. But I'll be back tomorrow after baseball to answer any questions you might have. Okay, so for the rest of the day, just work on the worksheet and do some practice problems. And I'll see you all tomorrow. Have a great day.